If you didn't see the video on the Gigabyte H242, you should definitely check that out. This is the winner in terms of density and madness. I mean, with just 1200 watt, okay, dual 1200 watt power supplies, with just 1200 watt power supplies, you could rock 256 cores in this, although the 7713. Single socket per node, 4 nodes in this rack mount configuration. This lets you use the less expensive P-series CPUs from AMD. And this isn't Genoa, it's Milan. Well, it's Rome or Milan, depending on what your preferences are. Just because Genoa is out, it doesn't mean that Rome and Milan are going anywhere, at least right away. We're entering an era where servers and server CPUs are so complicated, there's so many pins in the socket, that it doesn't make sense to buy a CPU like that when an 8 or a 16 or a 24 core CPU will get the job done. So I think we're going to see longer lifetimes of SP3 and maybe even new stuff that's going to address that lower end of the market where they don't necessarily need 96 cores. And this form factor, to be able to do it, certainly is something. But what if you need a little bit more? What if you'd rather have 2 sockets per node? Well, Gigabyte's got the H262. Oh, it's a lot heavier. This is the H26Z6A. Now, instead of our plucky little 1200 watt power supplies, we are rocking 2200 watts in this form factor. There's 2 of them. It's madness. Madness. You can also see that we've still got 4 nodes at the rear, but at the front, we've got so much more depth to work with that we've got 1, 2, 3, 4 nodes worth of drives. 6 NVMe drive per node. It's going to give you a lot more storage options for local storage. Tiny little screw. Now internally, each node is very similar but different from the 242. First, 262, you got 2 sockets. Yes, 2 sockets. 16 channels of memory between 2 sockets. Obviously, you're leaving PCIe lanes on the table with this configuration. This is made for compute density. Although you do still kind of get a lot of connectivity. At the rear, we've got 2 full X16 slots as well as an X16 OCP3. So this is a pretty big upgrade over the OCP2 that we saw in the Z242. You've also got a Gen Z riser here for optional accessories. I'm sure that Gigabyte would be more than happy to design you some custom PCIe peripheral that will fit here, or a breakout cable, or an InfiniBand adapter, or just, you could go the liquid route and just start connecting servers directly over the PCIe bus. That is an option. To make room for all that, we go down from 2 M.2 on the motherboard to a single M.2 so that you can have that for your boot operating system or whatever. But remember, we've still got those 6 NVMe at the front. And we've got the same high density connectors at the front edge of the motherboard where all the connectors are actually used. On board, we've got our dedicated IPMI as well as 2 1 gig NICs for control, management, that sort of thing. And we've also got a mini DisplayPort. Why mini DisplayPort? Well, there wasn't physically room enough for VGA. These high-density chassis also have an optional accessory from Gigabyte. You can actually manage all 4 nodes from a central control interface. Actually, Gigabyte offers some software and some other customizations down that path if you are a large enough customer to want to buy a lot of these. Talk to them about that. But there's a separate network interface that's part of this chassis that will also give you remote console and remote control of the entire chassis. So you can see what's going on with it. The motherboard, if you want to read more about it on Gigabyte's website, this is the MZ62HD4. This is Rev 3 of this motherboard. You got to be a little bit careful with Gigabyte motherboard revisions because from Rev 1 to Rev 2 to Rev 3, CPU support changes, the BIOS versions matter, Redfish, etc., etc. It's pretty typical of enterprise boards, but sometimes that spills over into consumer boards as well, so you got to be careful. You got to dot your I's and cross your T's. Sometimes even support's confused. Now, if in this chassis you did not want to rock NVMe at your front panel connections, I mean, you got 6 drive times 4 lanes worth of PCIe connectivity at the front of the chassis. But if you didn't want to do that and you just wanted to use SATA for bulk storage, you can do that. SATA is routed out to those front 2.5-inch drives. 24 in total on the front of this. 6 times 4. That's how that works. Now, you might be wondering, what's up with these 2U 4-node configurations? Well, AMD's kind of the leader right now in terms of compute per watt, and the data centers are really on top of that. If you had a data center that was designed in the 1990s or early 2000s, which is not very old. It's brand new as far as buildings and construction go, but as far as data center goes, it's maybe a middle-aged data center before you have to do major retrofit and conversions. Power distribution inside those data centers is really kind of dicey. Nobody really predicted that the power usage of data centers would go up, 1,000% plus since the late 1980s, early 1990s, and a lot of data centers haven't really been designed around that. So density in a data center, but as you see, there's 8 CPUs. You could spend almost $80,000 on just processors for this one server. Just processors, not memory, not storage, nothing else, no networking, $80,000. This is a popular form factor for high availability and resiliency. If you're building a cluster, having a high availability N+1 cluster, you've got 3 nodes plus a spare in one chassis, is a pretty big deal. Now, people that are really spending this much money on a chassis like this, if you're going to get the more expensive, dual socket capable CPUs, I mean, the price difference between an AMD EPYC CPU that has the P designation, meaning that they only work in motherboards that have a single socket, is thousands of dollars per CPU. So you really have to be running an application where it makes sense that you need 2 CPUs and the memory close to one another versus just buying more single socket servers. And a lot of the use cases in a big data center for lots of different customers, virtual machines, virtual desktop, web servers, database servers, a lot of the time it makes more sense to have a bajillion smaller machines than it does bigger, more powerful machines. You still see this in higher education and research institutions and things like that, but generally not so much. And these PCIe lanes, they would add 400 gig Ethernet, InfiniBand, something like that, and that's your interface. And so these are all just compute, and whatever storage you have here is just caching and local storage. But these are unique in that you can run a 2 processor configuration. So, if you wanted to have 128 cores, you could. Alternately, if you're running something like the F series CPUs, the higher wattage CPUs, that can be supported in some configurations. Again, you might want to work with Gigabyte and figure out the particulars of that, because those F series CPUs are not as power efficient as the other CPUs like the 7713, which is the industry leader in performance per watt. It's not the fastest 64-core CPU that AMD has, but it is the most efficient. And you can rock 2 of those in this chassis, which is just it boggles the mind. And this isn't even Genoa. This is last generation. But last generation sometimes, it hits its stride a little bit later in the product cycle because, hey, these cost less. And hey, these aren't as complicated to build, although they're fabulously complicated to build. But, versus the larger Genoa footprint that has even more memory channels and more pins in the socket and more connectivity and everything else, it's like, I don't know which one. Listen, AMD is going to sell every single CPU that they make for this socket. They're going to sell so many of these CPUs, they're going to probably wish that they had made more, and they're just going to be wandering around the warehouse and be like, oh, we lost a box of 64-core CPUs. Put that out. We got to sell that. It's got to go. Because these CPUs are going to be useful in terms of computation for 5, maybe 10 years. I mean, look how long-lived some of the older platforms have been. These are going to enjoy similar longevity, and I think AMD is starting to realize that. Not just because not everybody is prepared to pay prices for 12 channels of DDR5 and the economic conditions in a macroscopic level being what they are, but because systems like this get the job done for a lot of people. And the more we can hang on to commodities, the better they're going to sell. So you get 4 of these in a single chassis, and each one of them is the same. They can go in any slot. You can move them around. So for spare parts and viability and reliability for those kinds of configurations, you buy 2, 3, 4 of these chassis, and you've got a really resilient system that will recover against, complete chassis failure. Okay, if your cluster was spread across a couple or 3 chassis, 4 chassis, it was a large cluster. You got 12 machines in your cluster. It's mostly a compute-bound cluster. You're good to go. If you're looking at VDI, virtual desktop infrastructure, and you're looking at the most powerful VDI option, you really have to consider graphics acceleration. With just 2 slots, these aren't great chassis for doing graphics accelerations in a VDI type workload. You can break out these PCIe slots into an external enclosure, something like what Liquid sells, and then you can rock all of your VDI accelerators. They're they're GPUs basically, just fabulously more expensive GPUs, but GPUs, and connect them through that. And then you still have your failover and redundancy. If you lose an entire chassis, it doesn't matter. You can reassign those PCI Express peripherals to another node in the chassis immediately without moving any cables or cards or anything, because that's getting into what composable infrastructure is. But if you can afford composable infrastructure, you're probably going for the Genoa SP5, DDR5 platform, everything else. These are good research nodes and compute nodes where you're going to need 20 or 50 or 100 terabytes of local storage to cache your stuff, but you're also going to need a really high-speed network connection to all of the rest of the cluster. This chassis doesn't provide any internal connectivity to other nodes in the system or anything like that. If you needed something like that and you had your, you're building a supercomputer, I'm sure that Gigabyte could customize the solution and build that for you. Gigabyte actually has a lot of customers in that enterprise. They have more of those kind of customers than they do, retail end user. I'm just going to buy $1 million worth of servers. That's probably like entry level where you start getting the level of customization. But it is an exciting time to be alive that more of those kinds of services are available to those, $1 to $10 million customers. Because back in the day, when you would buy those kind of things from, Dell or HP, it's like, oh, I'm going to buy $10 million of servers. And it's like, well, okay, I guess we'll let you customize the RAM. You can customize the RAM method, and that's all you got. And now it's like, let's build some custom stuff in the baseband management controller so that you can remote provision these over the internet, and it all just runs Linux anyway, right? Now, with this node, it's also true that Gigabyte has done more engineering than just shrink a bunch of servers to cram in a 2U node and share the power supply. There's actually kind of a lot of intelligence here, and with how they've done the PCIe routing. There is an extra A-speed remote management controller in the chassis itself. We've also got a bank of 8 2U high RPM fans that are responsible for all the cooling here at the midboard. So you can see there's quite a bit of chassis here that's not accessible from the drawers. Because Gigabyte has done that, they're able to pack in a lot more here than really it seems like they would have been able to. Gigabyte calls that their CMC LAN port. I guess it's Central Management Controller, but it's a pretty big feature when you've got rack after rack after rack of these systems, and maybe sometimes you just rent a single one of these to a customer. Like you might go online and you might rent 4 of these, or just one, and if you rent just one, you just get one of these modules in this chassis, and then that one's yours, and then everybody else gets another one. It's not super unusual to see bare metal with the same level of automation as containers, and that's where a lot of the innovation is happening. You're running your own hardware, but you're still running, the Amazon API or the Azure hyper-converged stack, and you can deploy things to a new availability zone that's really just stuff that's on-prem, but that lets you manage your on-prem infrastructure and your cloud infrastructure seamlessly. And this kind of hardware feature is what enables that level of automation once all the software glue is in place. Unfortunately, a lot of that is still proprietary, but Equinix is really spending a lot of money and opening up a lot of stuff. Tinkerbell, I've been working on automating some of this myself with Tinkerbell, where you boot off the network and then it looks at the MAC table and says, oh, this machine needs to be re-imaged, and it'll just re-image the entire server with whatever you need. Tinkerbell will power some of that functionality, which is really, really awesome. And then there's also open source projects like Terraform, which there's tons of videos on, tons of creators entering that space, people making YouTube videos about Terraform and automation and Ansible and all this stuff, which is really, it's sort of an exciting time. It's crazy to me that this thing can run 1,000 threads, 1,000 x86 threads with terabytes and terabytes of memory, and just, it's an entire data center in a box, basically, a data center from just a few years ago. Anyway, that's enough rambling about the Gigabyte H26Z6A. I'm also looking for nonprofits. Do you run a nonprofit, or do you work with open source? Because open source being classified as a nonprofit is, at least in the United States, is kind of difficult. It's not a lot of fun. But if you need access to hardware like this, and you can do what you need to do remotely, I'm sort of setting up a system to be able to rotate in and out disk images on this kind of hardware to help test things. I'm working on some things with the Rust people, and I'm working on some stuff on the ZFS side with some of the ZFS people that want to test different configurations on higher end hardware. Glad to help facilitate that. Maybe I'll get some videos out of it too. I don't know. But for now, just trying to get it done. And Gigabyte was kind enough to send some of these are from trade shows, so I need to I need to figure some stuff out, and that's why there is kind of an older platform. But I've got some stuff planned for these because Level 1 Techs is the forever home of this hardware, so we can do some fun things in terms of projects and hosting and everything else, assuming I can get a little bit more hardware together in the form of RAM and storage and everything else. And one of those at Level 1 has been a quick look at the Gigabyte H26Z6A with 4 of the MZ62 HD4 dual processor nodes. Cores. You realize that this is a kilocore machine, right? I mean, oh, well, kilothread. I'm sorry. This is a kilothread machine. 64, 128, 256, 512, 1024 threads in one box. Okay, that's not really like people. We've had 1,000 thread boxes before, but these processors are insanely powerful. All right, that's enough rambling for me. I'm Windowless Level 1. I'm signing out, and you can find me in the Level 1 forums.